This video is going to be about factoring trinomials. Remember, a trinomial is a polynomial with three terms, and they're going to take on the following form: ax squared plus bx plus c. So this is a method called using grouping. Now I know that we already learned factoring by grouping in a previous video, and you need to know that for this problem. So if you don't know how to use factoring by grouping, you should go back and review that before watching this video. So let's write out the steps for doing this process, and then we'll do lots of examples. So problem one, or not problem one, step one. We're going to find two numbers, P and Q, such that they add up to the middle number. So the way we write that is P plus Q equals B. B is the middle number up here. And P times Q is equal to A times C. Now what is A times C? It's the first number here times the last number. First number times the last number. Alright, so we're looking for those two numbers. Now what if you can't find them? So if P and Q don't exist, the polynomial cannot be factored. In other words, it's prime. Now that's not going to happen too often, but you need to know what to do in case you can't find those two numbers. So step two, after you get the two numbers, you split up middle term into the sum of P and Q. For example, bx, instead of bx, you're going to write it as px plus qx. Remember, this is okay because we already found that P plus Q is equal to B. So all we're doing is we're rewriting it. But now you're going to have something that looks like this. And so we know how to factor things with four terms. We factor by grouping. So as soon as you're comfortable with factoring by grouping, just realize that factoring trinomials is the same thing, except there's one extra step, and that's figuring out how to split it up to turn it into the four terms that works. So factoring by grouping. Now one note I want to put, always remember to factor out the GCF first. Always remember to factor out the GCF first. Okay? Okay, let's do some examples. We want to factor 5r squared plus 32r plus 12. First thing we do is we find two numbers that multiply to be 5 times 12 and add to be the middle number. So let's write that down. 5 times 12 is 60, and the middle number is 32. So we want to multiply to be 60 and add to be 32. Let's write down all the things that multiply to be 60. We've got 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10, and that's it. Now notice that between these, 2 and 30 are the ones that add up to 32. So what do we do now? Well, step 2 says split up the middle term into the sum of the two terms. So we're going to split that up. Instead of 32r, we're going to write 2r plus 30r. And the other guys we just bring down because we haven't done anything with those. Now, step 3, factor by grouping. Remember what that means? We're going to group those together. We're going to group those together. So out of the first group, we can pull out the GCF, which is r. So we pull out an r. We have left 5r plus 2. The second group, we can pull out a 6. It's a positive 6. We're left with 5r plus 2. Now, because the 5r plus 2's match, I pull out 5r plus 2, and I'm left with r plus 6. And that is my factorization. Okay, so let's do another example. We're going to factor this time 2t squared minus 19t plus 24. Notice this is a similar problem, except we have a minus sign in the middle. I'll show you guys how to deal with that. So first thing we're going to do is we're going to multiply 2 times 24. That gives us 48. So we know we want to multiply to be 48, and the middle number is negative 19. So we want to multiply to 48 and add to negative 19. Let's write down everything that multiplies to 48. So we have 1 times 48, 2 times 24, 3 times 16, 4 times 12, 5 doesn't work, 6 times 8. Now, if we want these to multiply to be a positive, that means that they have to both be the same sign. So either both numbers are positive or both numbers are negative. But because they add to be a negative here, that means they have to both be negative, because if they were both positive, they would add to a positive. So which ones are they? It has to be 3 and 16, but I need to make them both negative. See if it works now. Negative 3 times negative 16 is positive 48. And negative 3 times negative 16, plus negative 16 is negative 19. So these work. So I'm going to split the middle number up. Negative 3t plus negative 16t plus 24, and then 2t squared. We're going to factor by grouping. From the first group, we can take out a t. We're left with 2t minus 3. From the second group, we can pull out a negative 8. We're left with 2t minus 3 again. Because the 2t minus 3's match, we pull 2t minus 3 out. We're left with t minus 8. And that is it. Okay, so these are 2 examples. Let's do a couple of more. So number 3, I want us to factor x squared minus 3x minus 4. Here we have 2 minuses. Let's see if this is going to change the picture. So the first thing we do is we multiply the first number times the last number. Now, if there's no first number there, you can think of there as being a 1. So 1 times negative 4 is negative 4. So we want to multiply to be negative 4. We want to add to be, the middle number is negative 3. Now, what are the things that multiply to be 4? We have 1 and 4. We have 2 and 2. However, if they're going to multiply to be a negative, that means that one of them has to be a negative. And I see that they add up to negative 3, so this combination works. 1 and negative 4. So I'm going to split the middle guy up again, just like the other problems. I have 1x squared plus 1x plus negative 4x minus 4. And I'm going to use grouping. From the first group, I can pull out an x. If I take out an x, I get x plus 1. Or 1x plus 1, it's the same thing. From the second group, I can take out a negative 4. Now be careful, when you pull out a negative, it changes the sign of both of them. So that means we're going to get x and then positive 1. Now because the x plus 1's match, we take out x plus 1 and we're left with x minus 4. And that is our solution. You can see that these aren't too bad. It's taking us about 1 or 2 minutes per problem, which isn't so bad at all. Want to do another one? Let's try 12x cubed plus 15x squared minus 18x. Now in this problem, if you were to do 12 times 18 first, you would have a giant number. Furthermore, notice that the patterns of x's don't match. Instead of having no power, 1 power, and then 2 powers, we have a power higher everywhere. Remember the thing we wrote down before, though. Always take out the GCF first. Notice in this problem that we have a GCF. The GCF is in fact 3x. So if we take out a 3x, what would be left? We would have 4x squared plus 5x minus 6. Now what we're going to do is we're going to factor this guy right here. 4x squared plus 5x minus 6. We're going to ignore the 3x for now. We're just going to factor this. So 4 times negative 6 is negative 24. And the middle number is negative 5. So we're looking for two things that multiply to negative 24 and add to negative 5. Well, we have 1 and 24, 2 and 12, 3 and 8, 4 and 6. Because we want them to add to a negative and multiply to a negative, that means 1 has to be negative. It's got to be this one. So 3 and negative 8 work. So we split the middle guy up. We get 3x plus negative 8x. Split it up, and we're going to factor by grouping. From the first group, we can take out an x. We get 4x plus 3. From the second group, we can take out a negative 2, and we get 4x plus 3. Because the 4x plus 3's match, we take it out. We're left with x minus 2. Now don't forget we pulled this 3x out at the beginning. We've got to put that back in our answer. So that is our final answer here. Let me do one more example. Oops, I forgot to write the instructions in the last problem. Remember, that was to factor here. So we're going to factor 2x squared minus x plus 1. This one looks easy enough. Nice small numbers. So first number times the last number is 2. The middle number is negative 1. We're looking for two numbers that multiply to 2 and add to negative 1. So what do we have that multiplies to 2? We have 1 times 2, and that's it. But remember here, we have to multiply to be a positive. So they're either both positive or both negative. If they're both positive, they're going to add up to 3, not negative 1. And if they're both negative, they're going to add up to negative 3, not negative 1. So nothing works. So P and Q don't exist. What does that mean? That means that the polynomial is prime. It does not factor. So just as important as knowing something factors is knowing whether it doesn't factor. You can always tell if the numbers don't exist. So if you always just list all the products out like we've been doing, you'll know right away if something factors or not. And that concludes the video. Thank you very much for watching.